So let's get a quick lesson of what's happening in the world. Antarctica has a lot of ice on it. It's 7 times bigger than Greenland, so it is the biggest source of potential sea level rise. And I want to give you a quick little description of where potential sea level rise can come from. This is a photograph in Greenland I took that shows how the water is aggregating and finding these channels or chimneys to flow down to the base of the ice sheet now. And they're called moulins. And in fact, National Geographic has had 2 different articles, one of them a cover story showing this incredible melt rate in Greenland. That's the big change story of the last decade or so. And it's very much part of sea level rise. As the water goes down, it either gets to the ocean and raises sea level, like adding more water to a glass, or it gets underneath the glaciers and allows them to ride on water instead of grinding their way on bedrock. So the glaciers are speeding, doubling, tripling, and quadrupling their speed. And as the glaciers get toward the ocean, they do add to sea level, like putting more ice cubes in a glass. I don't know if this film clip's going to work here. Let me just see if I can get this. Okay, this is showing something from 2008 in Greenland.
That V section right there.
They were doing a film which you can rent or buy called Chasing Ice. It's a wonderful little film, actually very terrifying. Just showing you a scale of what's happening in Greenland that's hard to imagine, that was not in any of the models.
Look at the whole thing.
I think this clip is 4 minutes, and we'll get back to kind of... This was a 3-year project funded by National Geographic and the National Science Foundation, and they had 30 or 40 cameras around the Arctic waiting to show what's happening. They had no idea what they were about to film. At the start of this, the guys were saying, yeah, James, they were radioing into their base and saying nothing much is happening, and then, oh, I think something's happening. And then in a span of 45 minutes, the world changed. It gets worse. In fact, they really couldn't anticipate. They just have to keep panning back and expanding their field of view. No, this is real-time photography. May 28th, 2008. I saw that, I've seen that glacier. I was there in 2007. I was there the year before. That looks like a whale. It's really a dark carbon, black carbon layer in the ice that's turned upside down here. But models don't do this. Models don't show tipping points. Models don't show collapse. Models tend to be linear until we can actually have enough examples to create a model. This has never happened in human history that we've warmed this much.
The calving face is 300, sometimes 400 feet tall. Pieces of ice were shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these 2 little dots on the side of the mountain. And we watched and recorded the largest witness calving event ever caught on tape.
So how big was this calving event that we just looked at? We'll resort to some illustrations again to give you a sense of scale.
That's the producer, James Bellog.
It's as if the entire lower tip of Manhattan broke off, except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. That's a magical miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.
That's the kind of reality and picture that's worth, 1,000 words. We'd never imagined that that could happen. It's happened. That was 7 years ago. The planet's 1.5 degrees Fahrenheit warmer than it was a century ago. Almost 1 degree Celsius. That's huge. It's a global average. In the Arctic, it's much worse because it's an averaging effect again. Even when we get colder winters in the Northeast and we get more snow, we tend to look at things locally. How does it affect us? We tend not to step back and look at that, average picture, which gives us an apples to apples comparison, the kind of statistics we look at to have an unbiased view of the facts as opposed to some anecdote. People say, how come it's colder this year if it's global warming? Well, it may be colder where you are, but what about all the places where it's much warmer? And the Arctic's one of them. It's out of sight, out of mind. We have other problems. We mentioned last night, for those of you that were here, the methane. Somebody brought up the question. And methane is an even bigger factor than carbon dioxide in terms of warming things. In fact, it's much, much larger. And methane is here being flared out of a lake in Siberia. There's no pipe underneath that hole in the ice there. That's just a Siberian lake with the ice sheet in wintertime trapping the gas that's coming out of the ground underneath, the permafrost and the slush in the seabed or lake bed here. And they're actually burning it. One person there actually pipes it into their house and uses it for cooking. That's great use of energy, I guess. The point is, the planet's changing, just as we're changing. And we need to look at a picture holistically. I think holistic is the right answer. This is not the end of the world. And one of the things, I'm going to show you a couple of more slides in a moment, but this is a picture I took of my daughter and her friend a few years ago at the beach. And I said it last night, but I really believe it. This is not a gloom and doom picture. This is a picture like aging, like disease, cancer, or other things. We need to deal with it. We need to look at our options. We need to say what's caused it. What are our options to deal with it? But we also need to look positively to the future, and I really do believe that. And my daughter, who's now 14, helps me do that every day. Sea level rise and climate change is not a catastrophic event in the sense that a tornado or a tsunami or an earthquake is that we have no warning about and is going to catch us off guard. In fact, it's quite the opposite. We now have a century of warning, decades of warning, to begin to think different. And different than a storm, again, which hits one area and may or may not hit, and you don't know when, you don't know how big. Sea level's just going to keep rising. It's going to keep rising for hundreds of years. It's going to move the shoreline inland. As sea level rises because as the ice melts, means that the next storm or the next extreme high tide is going to be even higher. Has an additive effect, but it doesn't recede. So why does sea level rise? Well, it's, again, as I said from the beginning, it's not the melting Arctic. We tend to think of the polar bears. But what the Arctic does mean, there's two messages I take away from the Arctic. One is that we go from bright white ice to dark ocean. It's like taking a white roof on a house and painting it black. It's going to absorb more heat. And that's changing the temperature inside the house or inside the ocean. And that's a problem. So it's a feedback loop. But the second thing is it's a great proof and teaching tool, because people say, oh, Mr. Englander, I think that this has happened before. You scientists are just exaggerating it, grant money, and you're taking this out of context. This has all happened before. I said, well, it has happened before. But it was 3 million years ago that the Arctic was ice-free. It's going to be ice-free in our lifetime. If there's any confusion whether we're in a new era, ladies and gentlemen, The fact that the polar ice cap will be ice-free for a few days and then a few weeks and then eventually a few months in September, sometime in the next decade or two, that it is unstoppable, should give us pause and get our attention and say, wait a minute. Sure, we have seasons, and sure, we have unusual storms, and there's some years there's no hurricanes, and some years there's lots of hurricanes, and we can get earthquakes. All that's true. But the polar ice cap has been frozen for 3 million years, the North Pole. Antarctica has been frozen for 30 million years. That's geologic fact. That's not an opinion. People get confused because the peripheral sea ice around Antarctica is growing. That's exactly what we would expect to happen. Has no effect on sea level. It's consistent with global warming, surprisingly. Be glad to explain why. The facts are the facts. And the fact is that the Arctic is going to be ice-free in the next 20 years, and then it will refreeze during the wintertime, but thin ice. When I dove under the polar ice in 1985 and 1987, it was 10 feet of ice we had to drill through. That's gone. There's hardly any 10-foot ice anymore. That was the perennial year-round sea ice. Now we get thin ice building each year. Antarctica to the Arctic, it's all proof of warming. And again, you have to understand things either to not make an incorrect assumption that growing sea ice around Antarctica means the planet's cooling. It has nothing, that's unrelated counterintuitively. So I want to give you a quick picture of how this all connects. The amount of sea level that can happen potentially, as I said earlier, was 212 feet. Basically, just round figures, that comes down to 24 feet from Greenland and 186 feet from Antarctica. The remaining 2 or 3 feet is the glaciers. All the world's glaciers, from Alaska to the Alps to South America, Glacier National Park in the United States, all of those glaciers add up to 2 or 3 feet of sea level rise. That's surprising, but it's fact. Fairly simple measurement. The big problem is the ice on Greenland and Antarctica. And the one other factor we don't think about, but is thermal expansion of seawater. The oceans are already 1.5 degrees Fahrenheit warmer, as I said. And as a result of that, they're about 3 or 4 inches taller, because when things get warm, they expand. You know, parts in the wintertime don't fit the same way. Keys go into locks differently and things like that. Well, it's because of thermal expansion. And the oceans, because they've warmed 1.5 degrees Fahrenheit, or about 0.85 Celsius, they are about 3 or 4 inches taller. The rest of the 8 inches we've had so far comes from Greenland, pretty much, and some glaciers in Alaska, etc. It all adds up. This is, I mean, I love going on shows with deniers and people who want to spin this, because the facts are the facts. And I haven't been stumped in 2.5 years. And I welcome going to hostile audiences, because those are the people we need to enlighten and get to see what's at stake here in terms of our towns and our homes and our investments, etc. And it works, because sea level is a part of climate change that's a little different and gets around a lot of the confusion and politics that somehow become associated with climate change. The problem is when glaciers go from land to ocean, that's when sea level rises, as I showed you earlier. And the big problem is one place in Antarctica at the 8 o'clock position, shown in red there. That red is to illustrate the amount of movement in the ice. Basically reflects the amount of warming that's happened. And the movement in the ice is the problem. I'm going to now give you an aerial view of that same area at the 8 o'clock position, called the Pine Island Glaciers, the PIG, P-I-G. We sometimes use the acronym, but the Pine Island Glaciers are really a problem. There's 6 of them. And when those 6 glaciers slide into the ocean, we are going to have about 10 feet of sea level rise, just from those 6 glaciers. Won't happen for at least 20 years, because when you look at them, now we have great data. We can look at those glaciers from underneath with remote cameras and drilling through the ice. And in a very simplistic diagram, this is what they look like. But here's the problem, is that big glacier, these are marine glaciers, they actually rest below sea level. And they're being eaten away underneath, out of our sight, faster than from on top, because the water holds more heat. Even though it's cold water, it's we got a lot more heat content than cold air, if that makes sense. And it's now eaten back about 30 miles on the underside. And the effect of that is that because these glaciers go back about 100 miles, it's a river of ice, that gravity will drive it to the ocean. And there's what's called a grounding line there, which is kind of where the ground comes up, the bedrock, that will, for a while, prevent it from sliding. Does that make sense? Can you see that? Okay, so the grounding line is really important. And we now can calculate that based upon the current melt rates and even some of the projected increase in melt rates, that the grounding line will restrain these glaciers for about 20 years. But beyond that, there's nothing to stop them. Now, they're huge rivers of ice. They're not going to slide into the ocean in 1 year. We don't know whether it'll take a decade or 2 decades or 3 decades. And we don't know when it'll start. I don't think it can start for 20 or 30 years. But let's say in the second half of this century that those 6 glaciers slide into the ocean. It's now deemed to be less than a 5% chance. Some people say it's less than a 1% chance. But the odds keep increasing because the planet keeps warming. So it's not in our lifetimes, and for some of you it may not be in your kids' lifetimes, it's certainly in your grandkids' lifetimes. We're looking at in the latter half of this century and the early part of the next century. Now, for some of you, maybe you don't care. Maybe you don't have kids. Maybe you don't care what the planet's like after we're gone. But I suspect for most of you in this audience, you do care. Not for religious reasons, although that may be part of it. But it's kind of our legacy and how we're taking care of this incredible system that nurtures us, that supports us. It's a different viewpoint. You can see this. It's the opposite of looking at our bodies. But certainly it affects where we live, the temperature, weather patterns, and real estate. I mean, literally the shoreline. We hadn't thought of it that way. It's a new way of looking at it. And on top of the Pine Island Glacier shown there with the dark red arrow, there's a new area that's even in some ways more concerned with that striped arrow that just popped up, the Totten Glacier. It holds 22 feet of sea level rise and has the same structure, but it's a little behind in terms of the warming cycle. But so you add the two of them up, now we got 30 feet of sea level rise. Now, the scientific community was not willing to say it's going to happen this century, so they leave it out of the projections. The way that the IPCC and the other documents that look at projecting climate change work, they try and keep themselves to what they know will happen this century, that they can document, that's been in peer-reviewed literature, that they can quantify, that has a 80 or 90% certainty, because they don't want to scare people. And they don't want to say things which we're uncertain when it will happen. It's like saying when a hurricane will happen or when a tornado will happen. We don't know. Or an earthquake, right? Or an avalanche. But there's also, you know that in a certain period of time those things will happen. But here it's even more certain because the ice is there, it's moving, it's melting, gravity isn't going to stop, ice isn't going to melt at a different temperature than 32 degrees Fahrenheit, right? Those things are givens. This is going to happen. This is going to affect all coastal communities on this planet in the next century or two. It's really a different reality. Can you see that? This isn't a weather event which is a variability, and you can't exactly predict weather a year in advance. We know that. But we build for earthquakes based upon a 10% risk that within 50 years we'll get a Category 8 earthquake. We're now worried about building in tsunami zones, right? Where we're going to get a tsunami, which is again a seismic event, not a weather-related event. But we have it where we've seen disasters happen like earthquakes and tsunamis. We build smarter. And we say, let's plan for kind of a worst-case scenario, right? We're not doing that with sea level rise. And sea level rise becomes, as you can see, a really special aspect of climate change. And the amazing thing is, this is not a probability event. It's only a matter of how soon it will happen. It's sobering. I can see that it's got some of you either reflective or depressed, and I'm sorry about that. But it's just like a medical crisis. It needs to cause us to think different. And I'm going to bring you around to that in a minute, I hope.